An airport owner purchases a policy to offset costs associated with excessive snowfall. For every full 10 inches of snow in excess of 40 inches, the insurer pays the airport 200 up to a policy max of 500. The following table shows probability function for the random variable x of winter season snowfall in inches. Calculate the standard deviation of the amount paid. Now, the first thing to note here is that the payment starts for every full 10 inches of snow in excess of 40 inches. So the first payment would be once you go 10 inches in excess of 40 inches. So that means 10 plus 40, which is 50 inches. So the first payment starts at 50 inches. So which means that in these first 4 rows, as long as we are less than 50, there is no payment. So we have our first payment in this 5th row, and therefore the first 4 rows can be lumped together into x greater than equal to 0 and less than 50. And for all this portion, the payment is 0, and we can find the probability of this portion by adding the corresponding probabilities of the first 4 rows. 0.06 plus 0.18 plus 0.26 plus 0.22 is 0.72. So for x between 0 and less than 50, the probability is 0.72, and up to that point, there is no payment. So we're calling y as the payment. And the first payment starts when x is greater than equal to 50, because that's the first time we are in excess of 40 inches. So the probability of that part was given to be 0.14 for x greater than equal to 50 and less than 60. And that's the first 10 inches in excess of 50. So we're told that for each 10 inches in excess of 40, so we're told for each 10 inches in excess of 40 inches, we get paid 200. So the payment here is 200. And then once you go to the next interval, which is greater than equal to 60 and less than 70, the probability of that is given to be 0.06. And now you get paid another 200. So the total would be 400, 200 for the 10 inches before and 200 for this much. And once x is greater than equal to 70, so again, the max payment is 400. So the next interval, once you go 10 full inches above the 60 inches, you'll get a payment. So as soon as you hit 70, you get another payment, but this time it won't be the full 200 because the policy limit is 500. So once you hit 70 inches, you hit the policy limit of 500, and it's going to be 500 no matter how much you are in excess of 70. Therefore, we lump together the last 2 intervals. We look here, greater than equal to 70, and that would be 0.04 plus 0.04 plus 0. So all these 3 can be lumped together into just greater than equal to 70, because in this portion, the payment would just be its max policy payment, which is 500. So 0.04 plus 0.04 is 0.08. That's why we have a probability of 0.08 for the payment of 500. And we are to calculate the standard deviation, and the easiest or the quickest way I find in this case is to just use the calculator. So let's do that. And the y values are 0, 200, 400, and 500. So I will do data, and I would do hit data again, and then I would enter so that it clears. And similarly, I would do data again, and I would take it to the L2 to clear L2, enter. And now my data is cleared. So my payments were 0. Payments will be in the first column, 200, 400, and 500. Enter. And then I scroll over to the second column to enter the corresponding probabilities. For a payment of 0, the probability was 0.72 and For 200, it was 0.14, I think. Yeah. Let's go back to the Word file. For 200, it was 0.14. For 400, it was 0.06 and then 0.08. So 0.06 and 0.08. 0.06, 0.08. And then we do second stat. It's one variable stat. Data is in L1, frequency. So you enter, frequency is in L2. Frequency is the probability in this case. And we are always looking for the population standard deviation. So it comes out to be 163.5. And that is choice A.